Hello, everyone, and welcome to the first lesson of second semester. If you had me last semester, you know kind of how this works. You should. If you haven't had me yet, I'm going to give you a few pointers here as you watch these videos. Um, First thing, make sure your sound is on. If there's nothing happening right now, your sound's not on, you're probably wondering what's going on. Second, I'm going to kind of show you how the notes work. The name of the notes is right here, which lesson we're doing, and then the learning targets, what I'm hoping that you'll be able to accomplish by the end of these notes. If not by the end of these notes, then by the end of tomorrow when we go over this. So here we go. So we'll go get started into our first lesson, which is interpreting graphs. All right, so each graph that we're going to look at has two axes, an x-axis, which is our horizontal on the bottom, and the y-axis, which is obviously the vertical. Each of these has a label. That's a very important thing that you need to see. Okay. Typically, the x-axis is going to be labeled time, and it can be measured in many different ways. It can be seconds, days, years, minutes. You get the idea, but it's going to be some form of time. The y-axis is going to come with a variety of labels, but the most common ones you're going to see are speed, distance, or total distance, things like that. So, but there could be others. So let's look at the first example and see what we're looking at here. So the graph below is showing a trip to London as you're flying from New York City to London. All right, so the graph shows you, and one of the most important things you look at is the y-axis and what its label is. It's altitude. So altitude is height above sea level. So the altitude of your plane as you fly on this trip to London. Okay, so what is this graph showing? It is showing the altitude of a plane over time. Where is the plane at its highest point? At the highest altitude. Okay, or in this case, it's at the cruising altitude. It's the highest off of the x-axis. So that is the highest point of the plane in this trip. Where is the plane going the fastest? Probably at the cruising altitude, but we actually don't know that. You can't tell from this graph. This graph does not show us anything about speed. And altitude does not tie into speed. Can't tell from this graph. There will be times when that's an answer. What does the flat portion of the graph represent? It's a constant altitude. So they're cruising at a constant altitude. So maybe 35,000 feet, but they're also at a constant altitude right there. I think that's the only other flat spot on this graph. So that's our first example. Let's take a look at the second one. So this one, you can see the title of the graph, A Commute Home. What is this graph showing? It's showing the total distance for a person's walk home. Now, total distance is a little, it's important to understand it's a total distance. It's not a distance from home. I'll talk about that with question 4. Where is the person going the fastest, and how do we know? Well, this, you might be thinking, you can't tell from this graph, but distance is related to speed in a way. If you cover more distance quicker, your speed is faster. So when the person is taking the bus, they are going the fastest in this picture. And if you aren't seeing where that's at on the graph, it's right here. That is where the line rises the fastest or the steepest, meaning you're getting more distance faster, which means your speed is faster. What does the flat portion of this graph represent? It's a constant distance. Now, we don't typically say constant distance. In fact, I won't accept that as an answer. Constant distance means that you are stopped. You're not moving. If you're moving, then you're increasing your distance. So if your distance is not changing, that means you are stopped. Not stopping, but stopped. Why does this graph never go down? The total distance the person walks can never decrease. Even if you walk backwards, the amount of steps you're taking is going up. So the distance here, the total distance, can never decrease. That's why the line is either going up or it's flat. All right, to the back, another example. This one does not have speed or distance or altitude. It's a different label for y. Temperature. You got to make a few inferences about this one. You have to kind of think about it a little bit. What is this graph showing? Well, it's showing the temperature over a weekend. It says weekend temperatures. So it's showing the temperature over the weekend, a random weekend. Which day was the warmest? You can actually tell from this graph that Saturday was the warmest because our weekends are Saturday and Sunday. The Saturday hump, first one, is higher than the Saturday or the Sunday hump, which was the second one. Okay, so Saturday was the warmest. Which season is being shown here? This is something that you can't tell. It could be summer, and Saturday was like 100 degrees and Sunday was 85 degrees. Or it could be winter, and Saturday was 12 degrees and Sunday was -3. We don't know. We just know that Saturday was warmer than Sunday. That's it. Okay. Which scenario best fits the graph? So this one, a lot of people are going to choose A because that looks like you're drawing what's happening. Like Billy skates up a hill. It looks like you're going uphill, maintains his speed for a while. So flat, that makes sense. Goes up a very small hill and then quickly descends down a very steep hill. He goes up a smaller hill and finally comes back to the ground. If this label were distance above the ground, then that would be correct. However, this is not saying that. It's saying speed. So the speed is increasing quickly. And then it increases a little bit more. And then it slows very quickly. And then it increases a little bit, holds steady, and stops again. So which one shows that scenario? Billy slows as he goes up a hill. No, he's not slowing as he goes up a hill. He's actually getting faster. So B is out. It's got to be C, but let's read through it. Billy, typo there, skates down a hill, maintains his speed for a while. So skates down a hill. That's going to increase your speed, right? So you're going down a hill. Yes, it looks like you're going up a hill, but you're not. You're going down a hill, which is going to increase your speed. You maintain your speed for a while. That's this part. And then pick up speed again. Yep, that's going up a little bit. And then a sudden stop. He then increases his speed again is constant for a while, which is what you see here. And then comes to a stop again. So C is our right answer here. Okay. Last one is sketching a graph. We're actually going to do two of them. Sketch two graphs of the Top Thrill Dragster at Cedar Point. If you know what that is, great. You have some reference here. If you don't, maybe type it into Google and watch the Top Thrill Dragster. I can describe it real quick. You are going up 420 feet, and the max speed is 120 miles per hour. It shoots you off. Basically, you start at a stop, and then it shoots you off really, really fast. Okay? And you go up 420 feet, and you come back down. That's it. So we're going to draw two graphs. The first one's going to be time. And the second one is going to be, the y-axis is going to be speed for the first graph. So you're starting at 0. So you start on the x-axis. And it shoots you off really fast. So you go really fast, really quick. And as you get to the top, you start to slow down. You don't come to a stop. Sometimes it does come to a stop, but normally it's going very, very slow. And then as it goes up the other side or down the other side, it picks up speed again and then comes to a stop. It doesn't get going quite as fast as when you started, but that's essentially what's happening. Really, really fast to start off, and it starts to slow as you get to the top of the hill. And then as it goes down the hill, it picks up speed again, and then it comes to a complete stop and you get off the ride. The second graph is going to look different. This is height above the ground. Well, when you're on the ride, you're actually above ground. If you were on the ground, that would be a problem. You're actually a little bit above the ground. It shoots you off, and you are actually staying at that same height for a little bit. And then all of a sudden, you go way up 420 feet. You turn around and you come back down. And again, you finish at that same height as you started. And then you get off and you come back down to the ground. Okay. So you can see that those two graphs look very different. It's depending on the y-axis. All right, so that concludes our first video of second semester. We're going to do the second one tomorrow.